Okay, so we had, for this one, we have the x, 7x minus 8 equals 0. So we set x equal to 0, 7x minus 8 equals 0. Adding 8, you have 7x equals 8. Dividing by 7, you have 8 sevenths. And I know it's habit to change it into 1 1/7, but it usually leaves it like this. So we have the two answers, 0 and 8 sevenths. That's the two answers. Don't put parentheses around them. This is not a coordinate. These are both answers. Okay, that's as far as our first video, okay? And how about one like this? 0 equals 25 plus x squared plus 10x. What do you see that we might need to do first on this?
X are common, right?
There's not anything they have in common. If we're going to factor it into two factors, into two binomials, don't we usually have an x squared first? We need it either in descending order or ascending, either going up or going down. So see, our x squared is in the middle, our x is here. So we want to put the 25 at the end. So we'll put 0 equals x squared, then the plus 10x, and we'll put our positive 25 at the end. Okay, now to factor this, you can do 1 times 25, or you can do 5 times 5 to get 25. They're going to add to give you the middle term of 10. So you'll use the 5 and 5, right? Okay, x squared, you're going to have an x and an x.
Plus.
Are they going to be positive? Yeah, because this is a positive, they're going to both be positives. So you're going to have x plus 5 equals 0 and x plus 5 equals 0. There's really no reason we need to write that twice. It's the same answer 2 times. So just solve it 1 time, subtract 5, and x equals -5. So this one only has one answer. Okay, let's try another one, a different kind of factoring we haven't done today yet. X squared equals 16. How would we get that to equal 0?
Minus 16.
Subtract 16. So you have x squared minus 16 equals 0. And what does this factor into? Do you recognize that as anything?
Prime.
The difference of squares?
Oh.
16 is 4 times 4, right? You either do 1 times 16 or 4 times 4, but this is the difference of squares.
How about 2 times 8, no?
Yeah, it could be 2 times 8, but this one definitely is, you only have 2 terms. Either it's going to be factored into difference of squares, or it'll be prime where you can't factor it.
So x.
We're going to use the 4 times 4, and remember the difference of squares is plus 4 minus 4.
Yeah.
One is added and one is subtracted. That would be an x in the front. So when you solve them, x plus 4 equals 0 and x minus 4 equals 0. One will be -4. The other one will be +4. They're actually going to be the opposite of what you have in here, right? Have you noticed that's what's happening? When you have x plus 4, the answer comes out -4. This one was plus 5, the answer came out -5. Like that. Let me see one from earlier. The +5 and +3, how they came out to be negatives when you solved them. A lot of them you could just look at it and solve it. The ones like this, you'll have to probably write it down to actually get the solution.
Can I see that one again, please?
The last
The
one?
answer, yes. The
5-3?
answer.
The 4-4?
Yes, that one, because I didn't write the whole thing down.
Okay. Since it was plus 4 minus 4, it solved out into negative 4 and positive 4. The opposite of what was inside here. Which actually was the same thing, but it was the opposite of what was in there. Okay, that's mostly 5-7 has a lot of factoring like that. Some of them will be those crazy ones. I guess we should do a crazy factor too, right? Okay, number 55 on 5-7. Number 55 says 10x squared minus 23x plus 12 equals 0. Okay, so we know the 10 can be 1 times 10 or 2 times 5, right?
10.
This one.
Oh,
Yeah, because it's not just an x squared, it's one of those crazy factors like from 5.3. Okay, the 12 has 1 times 12, 2 times 6, or 3 times 4. We'll need each one of these for the 110 combination, and we'll need it again for the 2-5 combination. 112, 2, 6, and 3, 4. Okay, so we'll have 1 times 10, 10 times 1. 1 times 10, 10 times 1. 1 times 10, 10 times 1. This one, the 2, 5. 2 times 5, 5 times 2. 2 times 5, 5 times 2, and again 2 times 5, and 5 times 2. Now we'll see if we can find the one that will give us where they add to give you a negative 23. We already know that if they add, they're going to be the same sign. So we already know the sign will have to be a negative.
Oh, no.
So we can go ahead and put the minus in here so we don't forget for later. And they need to add to give us 23. So that's what we're looking for, 23. Okay, here we have 1 times 1 and 12 times 10. 12 times 120 is way off. How about 1 times 10 and 12 times 1? That gives us 10 and 12. That's 22, that's close, but it's not right. So those didn't work. 2 times 1 and 6 times 10, 60 is going to be way too far, right? So 2 times 10 is 20, and 6 times 1 is 6. That's close too, but it's not a 23. Okay, 3 times 1 and 4 times 10. 40's way off. How about 3 times 10 is 30? That's already too much, right? So the 4 is just going to make it that much bigger. Okay, 1 times 2 is 2. 12 times 5 is 60. That's definitely not it. 1 times 5 and 12 times 2 is 24. 24 is too big. So we're getting down there. It's got to happen pretty soon. 2 times 2 is 4, and 6 times 5 is 30. We know that's wrong. 2 times 5, 10. 6 times 2, 12. Again, 22 like that. No. 3 times 2, 6. 4, that's 20. 4 times 5 is 20. That's still too big. We're hoping this is right, or we're going to have to do them again. 3 times 5, 15. 4 times 2,
8.
8. There we go. Finally, the last try. 15 and 8. So we have a 15. Oops, that's not a 15 and an 8 though, is it? Oh, that's cute. That's just wonderful in the middle of that. You want to hit capture?